Okay, when talking about security and pairing in Bluetooth, the first thing that we have to discuss is how the Bluetooth devices pair up. And there's a number of different modes that can be used to pair those devices. The first one, and really least secure, is JustWorks. And JustWorks is designed for devices that do not have a keyboard or a monitor. Um, the second one is Passkey, and this one is designed for the user to enter a six-digit number, and that number will then be used to pair the devices. Next would be out of bounds, and the out of bounds is using an underlying or different underlying technology to establish that pairing, such as like tethering. The issue with out of bounds is that the pairing method is only as strong as that underlying technology. Next would be the low energy secure connection. And this one is the most secure. It utilizes the elliptic curve Diffie-Hellman cryptography and should be used when at all possible. So the actual security and pairing happens in three phases. Phase one is where that pairing method is decided upon. So it may be JustWorks, it may be Passkey, it may be one of the four that we just spoke about. Also in phase one, a temporary key is agreed upon between the two devices. The temporary key is not exchanged, but it's simply just agreed upon. In phase two, the two devices generate, each of the devices generate a random number. The devices then exchange that random number and use the temporary key to generate a short-term key. And once the short-term key is generated, we then have a secure connection between the two devices. And then that leads us into phase three. Since we have that secure connection generated from phase two, in phase three is where we exchange the rest of the keys. The long-term key is generated and exchanged for future connections. So if you have a Bluetooth device that you're connected to and you're done with it, you turn it off, and you want to connect to it 2 hours from now, it'll utilize that long-term key instead of having to go through the pairing mode and then temporary key, short-term key. Instead, it'll just use that long-term key. It's faster. Then there's the identity resolving key, and this is used for private MAC addressing and lookup. So this identity resolving key helps prevent those man-in-the-middle attacks or an attacker from capturing the MAC address of a given device and posing as that MAC address. The signature resolving key is used for data signing. And using a combination of those 5 keys, we get that authenticated and encrypted connection that we're looking for. So in Bluetooth 4.2 low energy LE, they introduced a low energy secure connection. And the phases 1 and 3 are the same. Phase 2 differs slightly. In the low energy secure connection, no short-term key is generated. Instead, we jump straight to that long-term key. And as mentioned before, the low energy secure connection uses that elliptic curve Diffie-Hellman cryptography for the key generation and exchange. When at all possible, the low energy secure connection should be used because it is the strongest connection.